evening. Thank you for coming. My name is Arash. I'm a PhD student in the Software Innovation Department with my colleague Ansi Kulka. Today we are going to demonstrate this systematic literature analysis. So I'm not sure how many of you are familiar with the term, but gladly at the end of the day, we will demonstrate all the steps so you can do it yourself for your own studies. And at the same time, we are live. We have some online participants on the Google platforms. So I try to explain it in a way that other people can also understand me. That's why I cannot come to there and pass you stuff, because I have some tasks as well. So I will be mainly sticking here. So let's get us started with some general questions. Like, I want to know how many of you have ever done like systematic literature review or any sort of extensive literature review. Can you raise hands? Or have you ever worked with Web of Science, Scopus, Science Direct? Does those ring any bell? Okay, and have you ever read the article, scientific article?
Yeah.
Okay, perfect. That's a good start. So then I will do it in a way that we start to understand what sort of analysis we can do on scientific literature. Because if you imagine a paper, something like this, all the papers come with the title, abstract, some text, and some other metadata. So what we are doing here is we are going to leverage these data points in order to get a comprehensive understanding of what's really happening in a particular discipline. So you might have your own disciplines in your head. Somebody's interested in sustainability, somebody's interested in innovation. So the main argument here is that we have so much text nowadays indexed in these scientific databases like Web of Science, which is one of the dominant ones, with over 100 million articles such as like this. So the thing is that if you go and search, let's say, sustainability, you will happen to see hundreds of thousands of records. And definitely, you have no choice if you want to go and read all of them. It takes years. So you have to go in some systematic manner in order to refine these results, refine these records, to find the most important and impactful papers among the big pile of texts. It's the same concept as you do in your daily life when you search something in Google. If you find a good search inquiry, you will get to your result much efficiently, more faster, with high precision and recall. And if you do like a very vague search with not the right terms, you will happen to see millions of results and they're not relevant, so you will end up with some irrelevant information, and it definitely takes much of your time. So these are some articles. I want just you to look at them for your own visualization purposes. Just, you don't need to like read them or anything. We will have a discussion. If you want to read them, of course, please. We can share it. Like, we will go through an exercise which we don't need to read them completely. So, do you have software engineering background? Do you have attributes? Okay. So if we know an article as an object, what sort of attributes you can give me as like a data point from those articles? For example, we do have title. So title is one. It's like a unique ID in a paper. When you search something, you will find the terms in the title. And again, we have author.
It's considered bad form or bad habit to take knowingly write the same title as another person.
Yeah, that's true also. So what else you can give me? What you can find?
DX identifier.
Okay, that's a very complex one. Can you give me more data points? Like what sort of attributes you see in a paper? Very good. What else? Just use your imagination. Like, think as a database. For example, in the abstract, we have plenty of text. And if you do some text analytics, very minor ones, you can find some attributes from the abstract as well. So abstract is also a very valuable data source. What else? If you see on the first page, you might see this DOI. It's a digital identifier, which Antti also mentioned. So that's very unique for each article. So if you happen to see a scientific article indexed in some database, they have this unique identifier. That's also very important. As we are going to analyze these articles, we need these attributes and data points. Can you name any other data points? There is this part, very common in all the scientific papers, is called the citation part, the references. You happen to cite people, other people's work, if you're coming with another research. So it's like being on the shoulders of giants. So you're building your research on top of others people's work. And if you don't happen to cite, it's sort of a plagiarism activity. So that also is a very important metadata, because you can somehow find what was the other way of thinking in order to come up with this research. So you can track this evolution path. So citations are very important. It's so somehow you can see the building blocks of that paper. So if you even look deeper in one citations, what you can see, like, can you give me extra data points from that citation part? In the last page of our article, you can go and look at it. It's on the last pages. On the last page of the paper, there is this citation part. Can you give me, like, what sort of valuable data points you can find from this citation part?
The authors, the titles.
Yeah, exactly. The same thing. So we have a one line of the reference where you can see the author, the name of the article, the publishing journal, the year, again, DOI. So that will also repeat again, like title, abstract, not abstract, of course, but DOI, publisher. And again, if you go in detail to that particular reference, you again get another set of data. So these will go on and on. You might end up, I mean, if you track a paper's references to the extreme, you might end up with some literatures from 1500, so like 500 years ago. So that's very interesting. I mean, we can somehow, with these data points, we can build this evolutionary path of, like, evolving in a particular field of science. So if you are in particular looking at innovation, let's say, we can see who were the people start discussing about this term innovation and how it evolved over time, and now what people are talking about. So mainly what we built, it's a cloud-based tool which kind of enables you to do this sort of stuff. So you can go grab so much of data from Web of Science, that's a major database we are using currently, and then by running an analysis, much easier. Well, of course, and obviously you can find tools and applications already doing these things, but the novelty with our tool is that it's cloud-based, so you don't need to install anything. And when you perform this analysis, you kind of get it live as well. So the reports are coming live. The whole thing is running in our service. So right now, I'm going to give you a demonstration about a particular field, like how you can do it for your own respective discipline. So I wanted to now screen share the screens on, please. So
yeah, let's have a look. First, please enable the input to that projector. Should I put down the...
Yeah, it's fine.
Yeah. So fast.
let's click a button here.
Okay, just
Yeah. There we go.
okay. I recommend you to use your laptops to, follow the steps. It's much easier to learn that way. Gladly we have enough time so we can replicate the steps, so you can kind of get the idea how you can do it for yourself in your own time. So, have you ever accessed Web of Science with your Eduroom accounts?
Yeah.
Okay. How many of you are now seeing this web page? Can you navigate to that, or do I need to explain it for everyone?
I think we need to click.
Okay. Okay. So, if you happen to just search like LUT library in the Google and click on the first link, you will be in the page of LUT library. And then Nelly portal, that's a link. Did you find it? Just please tell me, chop me if you couldn't follow. So are we here, all of us? Yeah. Okay, so where are you now? Are you in this page?
Mm-hmm.
Okay, and do you see the Nelly portal on the? Yeah, here. I do. Okay. So, and then we go to Nelly portal. And then we will find a database. Web of Science, Science Diary, Scopus, these are all databases which they index scientific publications. So, and then you will just simply type Web of Science or web, or just type Web of Science, and then go. You will see the database's name here listed, and then any of them, if you click on, it will be okay, and we can go to that main interface. So everybody, you did it? Okay. So the idea here is that we are going to search a particular term. I'm going to give you an example. I will do my own topic, and then you can do yours as well. Or if you want, you can just follow the same steps as I'm doing, because it's a demonstration. And then we will get these records, we will get these data from Web of Science, and then we will use another platform, which is our platform. It's a cloud-based thing for analyzing these scientific literature, these papers, in order to find out what sort of information we can get from pile of documents. So if you are seeing this interface, you have to navigate to this Web of Science core collection. Make sure to go to this, otherwise we cannot get full data. So from the all databases, you just click on this little arrow, and then you are in the Web of Science core collection. And then think about your own query, your own keyword. Like you can use Boolean syntaxes, it's like and, or even wildcards like asterisks if you want to like do sophisticated search. But here, for only the sake of this demonstration, I will just keep things simple and without hassle. So for example, I'm going to search about entrepreneurship research. I'm interested about everything which is happening about entrepreneurship. So by saying the collocation, it's like I might also be interested in entrepreneurs, entrepreneurial, entrepreneurship, so there are different ways of expressing this word. So the best keyword which I can target all these related titles is using asterisks. So if I just type, and then I use a star, an asterisk, and that will include me all the ways of expressing entrepreneurship. So these wildcards, or the ways of the ways you can search for the terms, you can find it in internet just simply by typing Web of Science wildcards or These are, I'm just giving you keywords, so later you can find the information yourself. Or Web of Science syntaxes for search. So as you can see, these are all rules are written here, like how you can use and or not, these Boolean search operations, the same as wildcards, how you can use that asterisk or $sign, how they can help you with your, helping you for building the query. So where we are, yeah. And then again here you have multiple options to select them on. For example, title will go and look at the titles of the paper. It will just look if that term is available in the title of the 100 millions of papers here in the database. For the topic, topic actually includes title, abstract, and the keywords. So it's a broad term. So you happen to have this word in somewhere in an abstract of a paper, so that will also be your results. Well, author, author identifier, group of authors, editor, publication name. If you happen to know a particular journal, you can look for it, or the DOI also. So I will just keep it, again, simple. I will look for the title. And then you just click search. It shouldn't take long. I'm waiting for this result here. As you can see, it's still calculating. It's kind of a big number, I guess. That's why it's taking a bit of time. Because again, you're looking for a very broad term. But anyway, till that comes up, we can see here that how these are search queries. So like you can copy, paste these things in order to keep track of your searches. And yeah, you have the results. It's like 18,000, plenty of text, plenty of documents. So it's like if you just consider 10 pages for each document, you might happen to have hundreds of thousands of papers if you want to read. Plenty. And then you can find the results by the disciplines, like business, management, economy. For example, what type of documents you're interested in, articles, proceedings, paper from conferences, book chapters. So I'm just going to just shrink the data amount in a way that we can handle it for today's session. I'm just going to look at for the articles, like journal articles. So, and then by selecting that, I will refine. So I'm expecting 10,000 exactly. And then you have other definitely options, like you can shorten your publication years if you're looking for the newer ones, or language-wise, country, territory. You can again refine the searches based on that. So you can see here, 3,000 more is from USA, 1,000 more from England. So that sort of information you can and start refining your searches to the extreme. I mean, it depends what exactly you're interested in. So from here, what I do is, okay, here's the argument. Like, we kind of know that we are going to study entrepreneurship research. What sort of ratios or indications we have in order to select if an article is good enough to read? Can you help me on that? Like, I'm a student and you want to advise me that, okay, with which articles you need to proceed with your literature review research. What should I look here? For example, I have this time cited here. It means that how many times this paper is cited. So if this one is 0, or if I want to rank them based on the highest to lowest, then I happen to see, like, okay, this paper is kind of very important. It has 2,038 cited, like 2,038 specific literature has cited this guy or this work. So that's sort of an indication that, okay, this paper is very important and I have to consider that. And again, the next one also. But this is not the only factor we should go on, because if you just want to consider these numbers and the time cited, you will end up with very old papers. Like this one is from 2000, almost 15 years ago, 1989, 25 years ago. Because these citation numbers will accumulate. So if you publish now and 20 years later, these citations will accumulate. And the bias come with these citations is that, well, most often people from different disciplines, like somebody's researching zoology, they want to use some entrepreneurship like facts in their own research. So they just simply go and look at what are the most cited papers in that field, and they just cite it without even reading it. That happens actually in science, and it's an unfortunate thing, but it's a sort of a bias, and people also recognize it. So if you want to kind of see that what sort of research is very well cited and very well appreciated in a particular discipline, you need to come up with another ratios in order to find out these papers, in order to eliminate the bias. So what options we have here is we can download our data sets, our records, and then bring it to other applications. This is possible from Web of Science. You can do it. So from here, you can either save it to your reference management programs, or you can download your data. So from here, you go and save to other file formats. And then based on Web of Science regulations, you can get 500 records each time. So if we have now 10,000 more records, we have to replicate or repeat the steps 21 times. So I will go 1 to 500, and then 500, 1 to 1,000, and then you will repeat the steps for 20 more times. So for example, here I will get like 1 to 500 as an example. I will not go to do all of them. I have the data somewhere, but in order to just demonstrate for you. And then from here, you just select the full record and cited references. This is very important because we are actually going to build this network of the connectivity among the literature based on the citation data. So it's very important that you get these citation references. And then from the file format, please go and select the tab delimiter. If you're Windows, Win, and if you're Mac, I think it should be different.
Both should work, but with Windows, you should definitely choose Windows.
Okay, so yeah, tab delimiter.
Yeah.
For the record content, I cannot select this full record inside the references.
Have you select the core collection in the searching step? You have to, otherwise you cannot get the citation data. That's the only database. Core collection is the only database which offers you the full data, which includes the citations as well.
So just filter the database on the left side, or where do you?
Like, let me get back one step. So in this interface, in this section, you have to select Web of Science core collection. That's a database which kind of offer you citation data, which we will use later. I mean, of course, you can go with all databases. It gives you more results, but you don't have the citation data. Because this citation data is something which Web of Science is building for itself. And there are, of course, other databases like, if you want to go and look for patents, there is this Durbin Innovation Index, which is another thing. So, yeah, core collection, very important. So I'm just going to skip the part for downloading. I hope that everyone understands that how you're going to download. Just select the records, like 1 to 500, and go on till you cover all your results. And then select tab delimiter, and also make sure to select the full cited data. So I have everything almost downloaded in my folders, so let me go through that. So yeah, at the end of the day, you will happen to see some sort of text documents like that, tab delimited files, regarding to your size of the database. So as you can see, I have like 20 or so of these files here. And then the other step, what you need to do is to compress the file. Just simply zip the file. In the Mac, you can do it by compress. In Windows, also you have the same option.
I think important note should be to avoid WinRAR and 7-zip. We have had occasional problems with those programs. So just use the send to compressed folder option.
Is there also an issue with the naming? I mean,
that should work fine.
Okay. So, clear? Yes, and after you zip the file, you will happen to see something like this, like simple as zip file. So I will now navigate to our Nails project interface. So it's an open source application. You can see the codes. It's in GitHub, and we also have a running server on that, so you can analyze your data in the cloud. So just nailsproject.net. I will make sure that Wiki distributes the emails with the information to you, so you can just go and look it for yourself. But yeah, can you find it on the Google? It's just nailsproject.net. And there's a link to GitHub. You can go and look for the codes if you are very thirsty for that, and also contribute if you like want to. It's an open source community. You will see some explanation about the whole project. What is it about? We do have also publications about it. So it's a case study replication, how we demonstrate the whole steps on a case study. It's written on the publication. You can also go and look at it. And some explanation about systematic mapping study, as it's a field which we are kind of trying to automate. And then, yeah, here's the section about our online server. And then here is the link to that server. So if you just click on our online server analysis, you will end up with this page. It's like hammer.nailsproject.net. It's a subdomain of Nails Project. So, have you managed to get any data for yourself? Okay. Am I very fast, or how is the process? It's easy, actually. We do have some YouTube videos on how to do this step, so you can follow it later. So yes, here again a very simple form. Just name your job. What is it? That also doesn't really matter. Email is good to provide because it may take some time, depending on your size of the database. And then when the job is done, you will get a notification that go and look at the web page. So I will book myself. And then you just choose the file, that zip file we already generated. And then start the analysis. It will take a time, and actually it won't crash gladly because it's a queue-based system. So if suddenly 100 people start pushing some tasks into the server, they will be queued. So first come, first serve. I think I imported the wrong data. Yeah, this one. I already have the results here. So we will follow from here. And we hope that that also finishes by the time we're done. So as you can see, the amount of records I pushed, I actually downloaded 8,363 because I download the analysis, the data 2 months ago, and if you just mention that particular field of entrepreneurship, the results we got was something like 10,000 for articles. So we can see that in a 2 months' time, how much article is added into that particular discipline, how exponentially this trend is growing, and well, we need to come up with some systematic way in order to analyze what we are going to read, otherwise we're kind of lost. In 2 months' time, you can see how much text is generated. So very familiar table, graph, where you can see that the field is growing all the time. Nothing much interesting here, but yeah, important authors is very interesting in a way that you can see what authors are very dominant in this field, what people are very important and well known, and we come up with here with the ratio. It's like productive authors. It's a ratio based on the number of papers they publish and based on the number of years they are into a field. So we can see that how much an author is productive. Most cited authors as well. So this is based on their work, but this is based on the number of citations and attention they get from other people in a scientific field. Important publications is very also important, because you kind of understand that what type of journals are very active in publishing research about this particular discipline, let's say entrepreneurship research. And if you happen to do some research, you kind of need to target that, okay, Journal of Business Venturing is very important. I have to take a look at it because it's almost publishing the highest amount of research about the field I'm concerned. And then so on and so forth. You can see other journals here. Again, most cited publications, these are the journals which are getting more attention, more citations from other works. Important keywords can be very helpful, as the whole process of literature review is an iterative process. So you will build your query, and then you will refine your query in a way that you add more keywords, you exclude, you include. So for example, I looked for entrepreneurship field of research, but maybe in the next iteration I need to consider maybe some like self-employment. It's sort of the same concept, isn't it? So that's also important. And for example, if I'm not interested about a particular study in a particular region, we have China mentioned here as a country. So we might somehow exclude that from our query. And then it really depends on what you're exactly looking for, but this can give you some insight. This is the keywords kind of analyzed based on the abstracts. And the most cited keywords again. So obviously entrepreneurship is cited the most. And then, yeah, important papers. What we have here is, we have the records. This is the number of the record which you can find within the Excel sheet, which is also generated from this platform. A part of the time cited, we have other novel metrics calculated. So in degree is another ratio which can give you an idea that how much reputable is a particular research. So if you happen to see the whole network, the whole records as a network. So imagine that each article or each title is a node, and then we have definitely other nodes. We have 10,000 of different articles based on our records. And then imagine that if somebody is citing a particular article, there is an edge, there is an arrow. For example, if this guy is citing this guy, then there will be an arrow here. This is an edge. So in that network, there are, with this concept of network and terminology of network, it's like social network analysis, if you want to go and look deeper about that. There are some statistics developed for describing how is network density and how the clusters are kind of emerging. And in degree is also about that. So with in degree, we are kind of measuring how many citations are coming, how many edges are coming to a particular node. So that's the value we are reporting here. So, and also the PageRank. PageRank is an algorithm which Google uses, and it also looks at the quality of the links. So it depends highly on what is the quality of this particular article when it's citing another article. So it's a bit more complex with PageRank. Well, at the end of the day, with having this analysis, you can find out what are the most important papers in your records based on these three important ratios, as I wanted to call. So, for example, if you just look at the time cited, you can see that, okay, well, it's kind of highest time cited paper has the highest interview. It's kind of obvious. But again, if you go downward, you can see that, okay, there is a paper with less number of citations based on the following and the previous paper. But why it's hanging up in the list? Because it has high interview. This is an indication that, okay, this paper is very reputed and very important among the people doing entrepreneurship research. So these are the most top 25 articles you need to look at if you are looking at the field of entrepreneurship, as an example. And then we have another section. It's like a recommended part that what type of records you need to take a look, but you haven't already looked at. So these are all listed here. And then you have the interview and PageRank ratio for them as well. So for example, this work of Schumpeter from 1934, it's a very old one, but it's kind of a fundamental paper or research for the field of entrepreneurship. So we can kind of go very deep and very fundamental research by looking at these parts. So yes, that's mainly from my part. Here you have some exciting files to download where you can, if you start downloading files, you can have Excel sheets for graphing your network, so you can draw the visualization of your network. So that's the part which my colleague Antti will help you with. Yeah. I already downloaded here, so yeah, go ahead.
So, hi everyone, I'm Arash's colleague Antti. I also have background in social network analysis and studying how people work, and based on that we decided to extend our knowledge in that direction, and we created this system with Arash and Juho, and I will be showing you a couple of things about visualization. I won't be going into a step-by-step tutorial because it's done by a separate piece of software called Gefi, and installing that will take a while, so you cannot follow along too much, but it's very useful because now you have statistics. They give you some information, but they are still difficult to figure out, like, you know, who is most popular, what are the most popular places, and but what if you want to examine the individual relationships, or what if you want to produce good visualizations or details for whether it's a systematic mapping paper, whether it's a literature analysis section for your very own master's thesis. So, as Arash mentioned, that these graphs, like if you have a site publication, okay, it's we can think it as node when we go to graph theory. Then you know, there is this new guy. Let's say this is like, I don't know, your professor, and then he has done an important publication, and there, you know, whether this is a master thesis, whether it's a new publication, you can cite it. like we talked about. And we can build a graph from the citation data. And again, these guys have good data. Again, a citation. And that's how the scientific community works. Like, you must have heard the quote that people stand on the shoulder of giants. Well, this is how it happens. There is a piece of data, piece of publication. It gets published and you can use that. You don't have to argue for that. For example, I don't know, if you're writing a thesis about retail or, I don't know, sustainability, and some guy has published that this new method of algorithm increases sustainability by 5% or efficiency, and you are writing a thesis, you don't have to prove the fact anymore. You can just cite, and your professor will probably say, all right. So let's open the folder. I have prepared some material here. My recent area of interest is gamification, so I did a couple of searches based on that. And we have this output folder. You can download it and use it like you would like. So you don't have, after you have used this Hammer service, you get the analysis, you get the pictures, you can download them and basically use them for your master thesis, literature review, whatever. So you can be safely in the knowledge that the files won't disappear from the online service because you have downloaded them. But the next part is Gephi. I can actually, I think it was Gephi.net or Gephi.org. And it's a visualization platform which can make different kind of graphics based on these data sets we have downloaded. And we have specifically made files, CSV exports that you can import, and there are notes. And notes are these articles, and edges are the lines that go between them. And so let's open it up. Yeah, Gephi app. And it's open source, you can download it. I have gotten it to work on Windows OS X. I'm sure it will also work on Linux. Okay, and I have prepared the citation network just earlier today based on this data. It's opening up. Okay, and what it will produce, you can do this network analysis, and you just create a new project. You open the data laboratory, and you could say that Gephi is a Moody application. It's provided for free and it's open source. So with some machines you might have problems or you might not have. And again, it uses Java. People have different opinions about Java, but it will enable software to mostly work on any platform. But anyway, you go to data laboratory and you can do the import process. And what it produces, so let's go to this folder, yeah. What it will produce eventually, you will get a graph of data. It will show the citation network. Okay, let's go to. You can see author cooperation network or the citation network. And for example, here is Juho Hämäri digital games. And you can use different kind of search tool to emphasize it. And you can also, as an online supplement, you can create a okay, let's see if it works. Yeah, great. kind of like web-based based search system. So we saw previously that here in this output that Juho Hämeri was one of the most cited gamification researchers in this author. So, but what does it mean? What has he cooperated with? So in here we can, for example, write Hämeri and see, here is one paper. He has published in Computers in Human Behavior. And for example, it has been cited by, another publication. And here you can see the abstract, the ID, what's going on, and who has again cited his work. And I have done the graph in such a manner that the most influential or most central articles are colored in red according to this Google PageRank algorithm that uses Google uses a more advanced version of PageRank to decide which article goes to be the top result when you search. So you can think of this being also similar version. And Fasan is most important, CAP, and here you can see that Catherine cites this, and there are a lot of articles that cite her in turn. And so this is important, for example, when sustainability is a young field of science. You're not probably interested in gamification, but when you start to read articles about sustainability, you get to get a picture of what is going on, like who has written what. And for example, I don't know, did you attend last week this lecture by Birgit? Okay, she is a very established author in her field, and so you might be curious like what she has published. Okay, a search result gives you that, but then you can follow that who has Birgit cited, what fundamentals articles have been used by her, like what articles she thinks are worth using. You can use this tool to search that again, and when you find previous articles published by Birgit, you can find who has used her articles as foundation, and it can help you give a reading list. You can use this tool or just the basic results in here. To give you a reading list and get a like personal sense of what is going on in the field. It's very tempting to just use Google Scholar or Web of Science and just reading, you know, the top 20 results. But it doesn't give you a picture of how these articles are related to each other and how the field has grown. And for young fields of science, like, I don't know, gamification or sustainability, you are in a privileged position because there are not like under 10 years of research and you can easily get a sense of it. It's more challenging in other fields, like when was the first innovation or entrepreneurship paper research?
It's still under the debate, but you can go back up to like 1850. So almost, yeah.
It's much more to read.
Yeah.
So,
Antti, would you please show them how they can navigate to a paper by using the UI? As we do have the link.
is it in here?
Yeah, for example, we have the UI.
We have the paper by most influential according to PageRank is Dominguez. We can copy that.
And then the link is also there.
All right.
I mean, in order to find a real paper, like,
Is it in here?
yeah, it's all over the top, like result. Yeah. Can you see the? Yeah.
Yeah. You can copy the link and go to Result DOI and just paste in here. This DOI is the most useful tool ever because it's a unique number for each paper. And using this LUT library access, you can probably download the PDF and read it directly. Like if you search for this paper through Nelly or access it through Web of Science, you can reach the full access. And even here the abstract is visible. So if you use a reference manager or just download the PDFs for your convenience, you can like get the top 10, top 15 articles, and then you can start look at articles that have been used by these. As you can see, at least almost 800 Mendeley readers have considered this worth reading. So it's something. So do we have any questions regarding? Yeah, please go ahead.
Since we only have this one database for collection, like how inclusive is it?
It varies. It's the most extensive database that there is, but it has some gaps, especially regarding computer science conferences. And I think some of those might be slightly better covered by Scopus. But Scopus, S-C-O-P-U-S. But the second interesting database result is here. It's like most cited or most important papers that are not included in the dataset. I think this is the entrepreneurship dataset.
It is.
Yeah. So here you can see, for example, we have not downloaded the paper by Stunter, but a lot of papers that have been downloaded and analyzed by the system refer to Stunter. So you can see that this very old fundamental paper is here. And other, Kirchner, Knight, McLelland. And you cannot find these using the Web of Science, but you can use Google Scholar or something else to try to find this paper. For example, this is so old that it doesn't have a DOI paper, but if it does have, it's included here. And also, this can give you an idea of influential papers that you should read that are not in the Web of Science system, so it kind of covers that aspect. Any other points?
Which file in the output module that you use for generating them?
You need to install Getty, and then let's go to back and back. There. In the output directory, we have these citation edges and citation nodes. And how you do it is that you start a new project. New project, and go to Data Laboratory. And here you click Import Spreadsheet, and okay, you navigate this find this output, and then citation. Okay, let's do a basic map. Citation edges. Choose semicolon as the separator and edges table, and finish. Okay, in most installations you will have something here, but it's probably a compatibility issue with Java. So I'm not sure if I'm able to show that all of the process to you, but do not worry. We have at nailsproject.net, we have an excellent series of video tutorials, and in the last, you can click video tutorial series here, and we have this network analysis and visualization with Keppi section that you can view. Okay, let's not. Okay, then this is Juho, the third partner, is virtually present, and in here you can see, yeah, the import process. It involves some manual work, and it's like matter of taste and I don't know, maybe artistry to choose the color theme and the layout and other stuff to make it as pretty or as you want. You can, for my preference, I like this hot cold scale with red being most important and blue being the most distant from the center. And here you can see these, clusters of references. You have some papers that refer a lot, and then some that act as intermediates between these clusters of cooperation. And in some young fields, you can see that there are some clusters that have not been connected yet. Like you have these guys doing this stuff, and then other guys doing stuff elsewhere that have not yet cited each other, and they are like doing stuff in, they're separate words this far. So, any other points? Is there something you would like to address?
Yes, I think I can give you some perspective by some nice visualizations that what you can really get if you invest some time. Yeah. So yes. I will also make sure that Vicky sends you an email with all the information we almost discussed here. Like you had questions about the Scopus, other databases, I will mention those on that email, so you have the links there. Yeah, for example, this was one project we did for sustainable innovation, the TERP. And I visualized the data from 1932 till 2013 or 14, if I'm not wrong. So if I play this movie, I made a movie out of it. So you can see that in 1932, almost like 20 people were talking about this thing. And then, wait. Oh, I cannot play. Wow.
I think the video file is also in the Dropbox.
So let's see if I can play it the other way. Do we have it in Dropbox? Was it in the same folder?
Could have it been in the entrepreneurship directory.
I think I copy pasted from that place, so it lost connection.
It's in the Dropbox directory, Nails project, Juho Arash.
Sure.
Okay, I copied it over in Dropbox. It should be now in the LUT GS.
Okay. So is it the one?
Yeah.
Yes. So you can see the year is increasing, 1942, 1952. Authors are coming, but it's still they're not finding each other, so you cannot see linkages because of not having the fancy databases we used to have nowadays. And suddenly after some 1980, 1990, you can see that linkages. So authors start finding each other, their work, and the graph become more dense and connected and more populated with the linkages. So almost you can see how a particular topic has been evolved. Yeah, to 2014. And you can also do these visualization and this timeline trend in Gephi. You can add the times. So there are enough instructions how you can do it. So I just leave it for your own interest. And for example, this is another one. Oh, again, I can't play this one. Do we have this on the?
I'm not sure.
Okay. So this was another like visualization of how a particular term has been grown in different disciplines. So I was looking about innovation, sustainability. Sustainable innovation. And the fields, these are the fields. So the fields start popping up, and these are the years. So at the end, you could see that okay, this particular discipline is more important in business and management than environmental sciences. So you can see the difference that way. Yeah, that's pretty much it. And we do have videos, as Antti mentioned. We can almost do the steps from the beginning with the 4 video instructions we have in YouTube. And any more questions? How you see it so far? Is it easy? Can you follow it? Do you think is it any helpful?
I think this is additional material. Like I think when you are doing your master thesis or first scientific paper, this literature study, it's mandatory, but I think it's one of the most painful parts to start with, because you are not yet used to the way of reading and searching scientific literatures. And if you stay in the same field, after the first review, you have your articles saved somewhere, you know about the field, but when you start, you know only your teachers, you know only the textbooks, and most of them authors in the field are strangers to you. But we hope that this will help you to get familiar with all the excellent researchers doing work in the field.
Exactly. I mean, in my own practice, I happen to know about systematic literature review, maybe not very soon in my PhD career, but the time when I understand how I can perform systematic literature review, it's kind of relieving the way that I now look at disciplines. So if I want to start to look at a particular field of science, I think this is the most appropriate way you can approach. Otherwise, you find yourself lost among huge amount of papers. So this is maybe not the only way, but one of the most efficient ways how you can narrow down the most important papers you want to read in order to get the idea of the discipline. And yeah, make sure to contact us if you have problems running the tests, and we'll try to be helpful. Make sure to watch the videos as well before, so because it's kind of very detailed explanation there. And yes, the session is officially over, but the stage is open for you if you have questions and discussions you want to raise.
Yeah, and thanks to the online audience, I'm stopping the broadcast for now.